is the circuit parameter. This is 2, this is dependent current source, this is a independent current source, and you have to calculate the value of V0 and the potential difference between this point and ground. Okay, this is the two basic things. Now we take that this resistance this resistance is 1 ohm. Okay, this resistance is 1 ohm. So the current direction of the current along this direction. So suppose we take this current is I, and this current is I1, and this current is I2. So suppose this node is A. This node is A. If I want to calculate the value of V0, then first of all we should calculate I1. Okay, if I know the value of I1, then using V equals to I into R formula, we can easily calculate the value of V0. Okay, so this is node X, this is node A. So applying KCL at node A, we get that I equals to I1 plus I2. This is equation number 1, because this is incoming current and this is leaving current. Now applying KCL at node X, this node, the direction of the current along this direction, current is along this direction. So two are incoming current and this is leaving current. This leaving current is also I. Okay, so at applying KCL at node X, we can write that I equals to 0.6 V0 plus 12 ampere. So this is equation number 2 equation. Now if you see this circuit closely, then this is a branch. Suppose this is a branch AC, suppose AC, and this is AB. Okay, so this is a AC branch and this is a AB branch. B and C both are same point. So the value of the resistance of this AC branch is 5 ohm, and the value of the resistance of AB branch is also 5, because these two resistance are in series, that is 3 plus 2 equals to 5. So both the branch contain same resistance. This is 5 ohm and this also a 5 ohm. So these two current must be equal. So you can write that I1 equals to I2 equals to I divided by 2, because these current are divided by two paths with equal resistance. That's why these two current must be equal, and I by 2. I by 2. Now if from this equation we can write that I1 equals to I by 2. I put this value I1 in this equation, so it will be half 0.6 V0 plus 12. So here I put the value of I, so it will be 0.3 V0 plus 6. This is I1. Now here you see that the voltage across 2 ohm resistance is V0 and the current through this direction is I1. So you can write this V0, you can write this V0 equals to, here you see this V0 equals to I1 into 2, because the current flowing through this resistance 2 ohm is I1 and voltage across this 2 ohm resistance is V0. So you can write that V equals to I into R. So using this value V0, we can write that I1 equals to 0.3 multiplied by I1 into 2 plus 6. So it will be I1 1 minus 0.6 equals to 6. This will be 0.6. So in this side it will be negative. So minus 0.6. So R1 will be 6 divided by 0.4. So it will be 15 ampere. Okay, so current through this junction is 15 ampere. So V0 will be I1 multiplied by 2. So it will be 15 multiplied by 2 equals to 60 volt. So I have calculated the value of V0. So value of V0 is 60 volt, 60, not 60 volt, this will be 30. So this is 30 volt. Okay, 15 multiplied by 2 equals to 30, not 60. Okay, now this is the first question, that what will be the value of V0. Now we have to calculate the potential difference between X and ground node. Suppose this ground node is D. So all the ground node B, C and D, all the ground nodes. So all the nodes are same. So if I draw this circuit, that you can draw this circuit in this fashion. So this is X node. This is suppose X node. From X node there is a current source. This is 12 ampere. This is another current source, independent current source. This is 0.6 V0. All are same ground point. Now this is 1, this is 4. So you can join this. This is 1, this is 2. So this is 1 ohm, this is 4 ohm, this is 4 ohm. And from this 4 ohm there is two branch. One is 5 ohm. There is 5 ohm and another is 3 plus 2. 3 ohm and this is 2 ohm. This is A, B, C and D branch. So this circuit can be redrawn as in this fashion. Okay, in this fashion. So what will be the voltage difference between these 2 points? So first of all, the resistance across these 2 points. So R equivalent equivalent resistance between these 2 points is, this is 1 plus 4, this is series, plus 5 parallel to this, also a parallel, so 5 parallel 5. This is 5, this 5 is parallel to this 5, so 5 parallel 5, and both are connected with this series 1 plus 4. So equivalent resistance between these two node X and the ground node is this. So it will be 5 plus 5 multiplied by 5 and 5 plus 5. So it will be 5 plus 25 by 10. So it will be 15 by 2. So it will be 7.5 ohm. So the equivalent resistance at this point X and ground node is 7.5 ohm. Now the voltage potential difference between X and ground equals to, these two current are flowing through this 7.5 ohm. One is 12 ampere current will flow in this junction, that means through 7.5 ohm, and this also flowing through this 7.5 ohm. So the potential drop across 7.5 ohm due to 0.6 V0 current source plus potential drop across 7.5 ohm due to 12 ampere current source. This is the total voltage difference between these two node X and ground. Because this branch contains several number of resistance with equivalent resistance is to 7.5, so all these current are flowing through this resistance. That's why the voltage difference between potential difference between the node X and ground will be this. So what will be the potential difference across the 7.5 due to 0.60? So it will be 7.5 multiplied by 0.6 V0 plus 7.5 multiplied by 12 ampere. So if you calculate this value, then it will be, so it will be 7.5 into 0.6, value of V0. I have earlier calculated the V0 will be 30. Okay, so this is 7.5 into 12. So if you calculate this value, so it will be 225 volt. Okay, so potential difference between these two nodes equals to 225 volt. Here I have solved this problem using independent current source and